Okay, back to percentages for question 5. This is good. I'm glad this question's come up actually because we did 2 parts of percentages before, and this will be the third part. So the theatre group sold 4,830 tickets. This was 15% more than what they sold last year. So how many did they sell last year? How many did they sell last year is the question, and the relevant information I've highlighted. Okay, so last year they sold X amount. Okay, and then this year they've sold 15% more. So X plus 15%. Okay. So what is 15%? What would that be as a decimal then? Well, we times that by 1.15. Yeah. So that's just 1.15x. Okay. That's what this year is. So another way to write that, which is maybe a little bit near, is just to think, well, because we could go through that and solve that. Okay, that's one way of thinking about it. Is that last year they sold 100%. Yeah, so last year's 100%. And then this year, my handwriting is very bad, sorry. They're doing 100% plus 15%. So that's just 115%. Okay. So that's the two ways you could think about it in terms of equations. Okay. So we would then say, well, 4,830 is equal to 115%. In the same way we could have said that 4,830 is equal to 1.15x from that last example that I gave you. Okay, that's the kind of two ways. I think it's easier to maybe think about it in terms of percentages, because this could come up in the non-calculator, and for this point, this process is kind of what we would do for all percentage questions. Okay, so we're finding 1%, and then we're going to find 100%. Okay, so how do we get from 115 down to 1? Well, we divide by 115, and then how do we get from 1 to 100? Well, we times by 100. Okay, so 115 divided by 115 gives us 1, times by 100 gives us 100. Okay, this is the classic reverse change. Okay, now this is an equation. I'll just rub that out. So what we do on one side, we have to do on the other. So I need to do 4,830 divided by 115. So calculator, 4,830 divided by 115. That's going to give me 42. Can't believe I can do that in my head, shocking. And then times it by 100, 4,200. Okay, seems fine. And if you want to just check you're right, well, let's say 4,200 times 1.15, that gives us 4,830. Okay, so as we check, 4,200 times 1.15, because that's increasing it by 15%, isn't it? And that gives us 4,830. Okay, and like I said, the other way we could have done it was said, well, 4,830 is equal to 1.15x. So then 4,830 divided by 1.15 is going to give us x. Okay. So that's the two ways you could think about doing it. All right. Definitely, oops, definitely this method on the left here is the preferred method. Okay, so that's your reverse the change. You're starting off at 115. You're trying to get back to 1%, and then you're trying to get up to 100%. Okay. Marks for that are quite straightforward. Let's see what this says. Yep, no, this first line's a mark. Working at 1% is a mark, and then finally the answer is a mark. So actually with 3 marks, that's fantastic, isn't it? To think you're getting 3 marks for that question, but you're only getting 2 marks for what I'd say is very similar question up here. So right away, that's 5 marks in the paper just on percentages. So 5 marks out of 50, that's 10% of the marks so far have been just on percentages, and I would argue that's quite straightforward work. Okay. Question 5, loads of time, right? A spherical sweet is made by coating a caramel sphere evenly with chocolate, and the cross section is shown. Okay, so we've got a coating of it's made by coating a caramel sphere with chocolate. So this looks like chocolate, Pardon me. And this bit is caramel. I love who comes up with these questions. It must be, they're always very inventive questions. I do enjoy this. By this point, everyone would start eating their snacks in the example. Okay, the diameter is 24, so we're showing that already. Don't care. The thickness is 3. That's shown. Don't care. Calculate the volume of the chocolate. Okay, so we need the volume of the outside part. Now, if they never gave you a diagram, you'd be forgiven for thinking, what's going on here? But they do show you a sphere, and they use the word spherical. Okay, so that should get you thinking, how do I work out volumes of spheres? Okay, well, front page. Yeah, here we go. Volume of a sphere, 4/3 pi r cubed. All right. So that should be, again, you see spheres, you should think that instantly. Now, obviously, there's a bit of a twist to this one. Page, a little bit of a twist because we're trying to work out the chocolate section, okay, which is all the way around here. Okay. So how do you do that? Well, we know the volume of a sphere is 4/3 pi r cubed. Also, sometimes I like to take these little pauses just to give you a chance. I think I've said this before. Just pause the video if you want. If you see the question, pause the video, do it, and then feel free to just kind of skip to the end of the video to see if you got the right answer, or feel free to watch it and kind of listen to me kind of, harp on about nonsense because sometimes I will wander off. So yeah, sometimes I have a little break to give you a chance. Sorry, just in case you think I'm dying or something. So yeah, the volume of a sphere is 4/3 pi r cubed, and we're trying to work out the volume of this external section. Now again, when you see two shapes together, you should be thinking, right, I'm going to have a volume 1, or a volume smudge is what that is. Volume 1, just a little purple, all right, or a volume 2, okay, not or, and a volume 2. So if we want to work out the exterior shape only, I'd be working out the entire shape and then taking away the white section. Do we agree? So work out the entire, excuse the mouse, the volume of the entire section and then take away this internal volume. Okay, so let's call volume 1 the entire section. Okay, so that's going to be 4/3 times pi times, and it's the radius of the whole section. So that's going to be 12 cubed because it's 24 is the diameter of the whole section, half of that's 12. Okay, and the volume of the internal section is going to be 4/3 times pi, and the radius of the internal section, let's see, if that's 24 and this is 3 and this is 3, then we need to take 6 off of 24, so the internal section is going to be 18, isn't it? The diameter is 18, so the radius is going to be 9, okay, 9 cubed. So working out your radiuses is an instant hassle. People seem to make mistakes. They put diameters in or they don't calculate it properly. Okay. And the other mistake to make here is to watch your cubes. People see right now this is 2-dimensional. People think squared because it's area. Okay, but we're actually working out a volume. It's just we've got a slice through it, which looks 2-dimensional, but it is a sphere, a 3-dimensional sphere. So watch your cubes, okay, and watch your radii, radiuses. Okay. So this is volume 1 and volume 2. Okay. So calculators out. I'm just going to pause the video. Okay, so this is coming out as, let's see, 7238. I'll do 2 decimal places, 23. Okay, and that's going to be in millimeters cubed. And the second one, I'm just going to change. It's exact same in your calculator. I've just taken out 12 and I'm putting in 9, and that's going to give me 3053.63 millimeters squared. Okay, so we're nearly there. Okay, now again, at this point, we've just taken an equation that's already been given to us and we've substituted in a radius. Okay, that's all we've had to do. Okay, so volume of spheres is actually it's brilliant. All you need to work out is a radius. Okay, the only hard bit in this question is identifying that to get the exterior shape, we've got to do the total minus the interior. That's it. But even if you're not sure about that, just work out some volumes. Just work out the volume of the interior, the volume of the whole thing. Just do some volume equations. Okay, you pick up some marks. Okay, so I would then put a statement that maybe says volume of chocolate is equal to V1 minus V2. Okay, so it's going to be 7238.23 minus 3053.63. I calculate. So 7238.23 minus 3053.63, and that's going to give me 4184.6. And don't forget our units, which is millimeters cubed. Volumes is always cubed. Area, square area, volume cubed. Okay, and that's us almost finished. Just as I went to check the question, so don't forget to read the question. The last bit was give your answer to 3 significant figures. Okay, again, sorry, I should have highlighted that at the beginning. Sometimes I read the question and do it, and always at the very end, I just like to go back to say, right, I've actually answered the question. Have I got the right gist? Okay, and there's nothing, it doesn't matter if you have to do, if you do that. I think it's always good to double check. I'm not ashamed that sometimes I get to the end and then go back to the beginning and say, oh, whoops, no, didn't quite realise that. That's fine. So 3 significant figures. Well, what are 3 significant figures? Let's highlight our 3 significant figures because I'm enjoying using the highlighter function on this. Yep, there we go. There's our 3 significant figures. And like I always say to my first years, people will be sick of hearing this story. Find your place, look next door. Okay, so find your place, which is 8, because that's the last significant figure. Look next door, 5 or greater, add 1 more. Okay, now obviously the 4 there is not bigger than 5, so we don't have to round up, we're going to round down. And by rounding down, we get 4180. Then we need to put a 0 in there to keep the place value. Okay, we do not put 0.0 because that would be significant, having a 0 after the decimal place. Okay, but a 0 before the decimal place just gives it place value. Okay, so 4180, and we're still in millimeters cubed. Okay, now I tell you what, 5 easy, that is 10% of the paper right there on the volume of a sphere. So if you get that, I mean, start giggling, start laughing. That is brilliant. Okay, so you get a mark for evidence of the difference in 2 volumes. Okay, so you get a mark for actually writing this down. So I've written it down towards the end. But actually, if you started off by saying that, right, you've got a mark. The volume of chocolate is equal to the whole volume minus the interior. That's worth a mark right there. That's not even maths. That's just thinking about things. That's brilliant. Okay, and then you get a mark for each of your correct values. Okay, you then get a mark for working out the answer, and then for rounding. So I think that's brilliant. And again, I'm not sure how it would work. I think if you didn't even know what the right answer was, if you just rounded it, if you just made up a volume and then rounded it, I'm not sure if you'd then get a mark for it round to 3 significant figures. Let me just check the paper. Doesn't have that, but again, if you're really struggling, why not write something down and then just round it, just to prove you can round to significant figures. I don't know if you get a mark for that, but yeah, I think that's a fantastic question. 5 marks, okay? Writing down what you're going to do, substituting the radius into 2 equations. That's very easy. Taking those 2 numbers away, there's another mark, and then rounding it. 10%. So far we've 10% of the paper on percentages and 10% on spheres. Okay, so that's a fifth of the marks, 20% of the marks on something, on very simple stuff. So your confidence should be, you should be feeling good. Okay, if you had this paper. All right.